Find the area of the half circle cross section shown. So here, let's try to think about what's happening. We have to visualize this in 3 dimensions, even though it's kind of only drawn in 2 dimensions. I have the x-axis, the y-axis, I have this line here, and this curve here. And then what we're trying to visualize is this half circle that's sort of popping up out, forming a 3rd dimension. And so the base of this cross section, the base would form the diameter of the half circle. And one side, or one end of the diameter is on this curve and it goes through the point 23, and the other end is on this line and it passes through the point 53. So to find the area of half of a circle, we're going to use the formula 1/2 pi r squared. So half of the area of a circle formula. Well, r is the radius. I'm able to find the diameter here, and then I'll just cut that in half to find the radius. So to find the diameter, we're going to focus on the x coordinates here. So this total distance of the diameter is between 2 and 5 in terms of x values, or 5 minus 2, which is 3. So we're able to find this diameter is 5 minus 2, which is 3, and the radius is half the diameter, so 3/2. And then we'll come back over here to our area formula and plug that in. 1/2 pi times 3/2 squared. So 1/2 pi times 9/4. So if I square the top and bottom here, numerator and denominator, and then I end up with 9/8 pi. Now there are no units attached, but we do want to make sure that we understand that the units of area would be a units squared. So 9/8 pi units squared for area. Now let's find the area of the shaded region in the cross section shown. So again, we're going to need to try to visualize what's happening. So here's my x-axis, here's my y-axis. I have a line and a curve. Now the cross section is 2 concentric circles. So what we have going on here is we have this circle here, and then this inner circle here, and we want to find the area of that shaded region. So we want to think of it as sort of a washer or a circle. Find the area of the shaded region in the cross section shown. So again, we're going to have to try to really visualize what's happening here. This may be the first time we've seen anything like this. So here's our x-axis and our y-axis. We have a curve and we have a line. And so we have these 2 points here that form this distance between what we are going to call 2 concentric circles. So we have this cross section that is formed. This is like three-dimensionally here. What we have is this bigger circle here, and then we sort of carve out this inner circle here. So I want to find the area of this red shaded part. So the area of a circle is pi r squared, but there's 2 circles going on here. So we're going to have pi times, let's call it capital R squared, because we have a big circle with a bigger radius, minus the area of the inner circle, which we'll call pi times little r squared. So I'm going to need to find that big R, the radius of the bigger outer circle, and subtract, finding the area with that smaller inner circle. So how do we go about finding that big R and that little r? So the big R, we can see, is the radius of that bigger circle extends from this top point that's up here at 4, 6 down here to this dotted line here, which we're told is y equals -2. So it's basically this distance here that I want to find the value of r. Okay, so what's this distance here? So we're going to focus on, because we're thinking up and down, on the y value. So the y value here, up at that very top point, is 6. And then all the way down here, the y value at this green dashed line is -2. So how many total units is that? Well, if we think about it, we're going from 0 to 6, if the x-axis is 0, so that's 6 units. And then this is an extra 2 units away. So this line down here at -2 is 2 units away. So this is a total of 8 units. Now, the other way we can find that value is to simply subtract this top value, or this bigger value 6, minus this smaller value. So R is 6 minus -2, or like we said, 8 units. So this total big distance here is 8 units. That's going to be my capital R. That's my bigger radius. And then I'm going to need to subtract that little radius value. So the little radius value is going to be this distance here. That's going to be little r. So little r, well, let's look at the y value there. The y value at this point right here is 4. So this distance from the x-axis to this point is 4 units. And again, this little gap is 2 units, right? From 0 down here to -2 is 2. So this total distance is 6. But how could we get that? We can do 4 minus -2, which would give you 6. So we can essentially always do this y value, this top y value, this bigger y value, minus this smaller y value. So minus a negative gives us a positive. So this is my capital R, this is my smaller r. So to go about finding the area of this cross section, we're going to plug in our capital R, which was 8. So pi times 8 squared minus pi times 6 squared. That's 64 pi minus 36 pi, which is a total of 28 pi. And again, we're talking area, so 28 pi units squared. If the cylinder shown below, which doesn't have a top or a bottom, is opened up and laid flat, what would the area of the shape be? All right, let's visualize what's going on here. I have my x-axis, my y-axis, a line and a curve, and then I have this cylinder where this point on the cylinder is passing through 4, 6, which is on the blue curve, and then this point, 4, 2, is on the purple line. That's the bottom part here of the height of this cylinder. What's going to happen if I sort of open this cylinder up? So if I think about, maybe cutting it, so getting a pair of scissors, think about it as paper, and I'm getting scissors and I'm cutting it right here along the seam. And remember, there's no top and no bottom. And then I unroll this out. What shape is it going to be? Well, it's going to be a rectangle. See if I can make it look like a nice rectangle. Okay, it's going to end up being a rectangle here. And so what would the area of that rectangle be? So rectangle's area is length times width, or width, height, base times height, however you want to think about it, right? So width times length here. So I can find the height here because we have these 2 points. So I can subtract the y values. I'm thinking up and down. I'm focusing on these y values here. So this is a height of 4. So we have this is a height of 4. But I have to think about, what's this width or this length, whatever you want to call it down here. Well, remember how we got this? We unrolled this cylinder. And so right here, that cylinder, that bottom part, forms a circle. And so what I'm interested in here is the circumference of the circle. That would be the length all the way around, which is equivalent to this laid out. So the circumference of a circle is 2 pi r. 2 pi r. Well, r is going to be the radius of this cylinder that we have here. What's the radius? Well, look, I'm given this value right here as x equals 6. And I also have this coordinate point over here. Let's focus on this point, 4, 2. So if I want the radius, which is the same from this vertical line to the right or to the left, so this is also r, I can find that by subtracting the x values here. So if I focus on x equals 6 and x equals 2, that means that my radius, right, on both sides is going to be 2, right? The radius is 2. The radius is 2. So 6 minus 4. So the circumference is 2 pi r. The value of r is 2. So that means this is 4 pi. So what is the area of the shape? Well, the shape is a rectangle. The area base times height, or length times width, is going to be 4 times 4 pi, which is 16 pi. And we're still talking about area, so units squared.